Dear fellow scholars, this is a channel with a host. Today we are going to have a look at the new ChatGPT 4.1, the latest upgrade to the famous text-to-text model. What has it got for us? Well, one new thing that it can do is this. Yes, hold on to your papers. It can now summarize a research paper and cite the important parts. But wait, don't go anywhere. This is not as easy as it sounds. Summarizing a research paper is hard because we not only need to distill the key ideas, but also find the important passages in the paper that led to these conclusions. This requires understanding the context, the background, and the related work, motivation, the experiments, the results, and so on. This is properly understanding the entire paper and distilling its key ideas. And you know what? This is proper text summarization, and it requires all the capabilities we expect from a good language model. So let's see how well does ChatGPT 4.1 perform at this. For that, we will have a look at a benchmark where human experts have done this for us, and we can compare against that. Here is the Corona benchmark. It contains summaries written by humans of 204 papers across multiple domains such as biology, chemistry, computer science, and economics. We can ask the model to summarize a paper and then compare the result to the human summaries to see how well it did. I wonder how well will it do. Will it be able to summarize a paper, and will it be able to identify the key facts and figures in the text? Well, let's see together. We start with an example. This paper is about frozen frogs and whether they feel pain when being defrosted. Now we can ask the model. Here goes. Please summarize this paper and indicate which sentences were most important in drawing the conclusion. The model starts working. It reads the paper, thinks for a moment, and gives us a summary. That is excellent. It identified the key fact that frogs do not respond to painful stimuli when frozen. So that's good. And then it mentions that this lack of response is likely due to the reduced activity of neurons. And again, it found that part in the text too. So far, so good. Now it is time for the test. Does it contain the correct references? Let's have a look. Yep, there it is. Lines 15 to 20 are cited. And if we scroll up, lines 15 to 20 say exactly what we wanted. This is incredible. This means that the model understood the paper and found the right supporting arguments. Wow. But it gets even better. Look here. The references span multiple paragraphs. It didn't just pick out a single sentence, but it found the relevant part of the discussion, and that is multiple paragraphs down. Incredible. But one more thing. These are not the only claims that the model makes. Look here. It says something about the structure of ice crystals disrupting neuronal membranes. Now that sounds interesting. Is that mentioned in the paper? Let's have a look. And yep, there it is. Now this is really cool. Not only did it find the main ideas, but it also found this additional supporting argument in the text. Fantastic. Now we would like to know, how often does the model get this right? How does it compare to a human? Let's have a look at the benchmark and see how it performs on average. For that, we go to the evaluation page of the Corona benchmark and look. Oh my goodness. A score of 1. This is perfect. It identifies the correct sentences with perfect accuracy. This is unheard of. You see, in academia, it is very common that we compare different methods by averaging over many tasks. So for instance, if we have 3 tasks and 2 methods, we would average over the 3 tasks and see which one is better. However, this is unnecessary here because here there is no variance. The model is perfect on all tasks. Wow, this is the first time I've seen anything like this. I am really out of words. And we are not done yet. There are many more amazing things about this model. For instance, look here. It also writes out pseudocode for algorithms, and it cites the relevant part of the text. Look here. It found the algorithm, and here it cites the relevant part of the text. This is proper scientific thinking. I am truly out of words. And you know what? If you wish, you can also tell it to write pseudocode for finding the shortest path between 2 nodes in a graph. And look, it wrote the pseudocode, but it also cited the relevant part of the text. Isn't that amazing? This is true scientific thinking. What a time to be alive. Now you might be wondering if there's any way we can make this even better. Well, one thing we could do is ask it to read a paper together with us. So far it read the paper all by itself, but perhaps we could help it along. So we could highlight key parts of the text, and perhaps it would find the important passages more reliably. Indeed, let's try that out and see whether that helps. Here is the same paper, and I will highlight the parts that are about the frog's behavior. And then I will ask the model to summarize this paper and indicate which sentences were most important in drawing the conclusion. Interesting. Now we are helping it along by highlighting the parts that are about the frog's behavior. And look, it still says the same thing. So perhaps highlighting isn't strictly necessary, but it could help if the paper was longer or less focused. We'll leave that to your experiments. And once again, let's check whether it cites the correct passages. Yes, it does. Absolutely fantastic. And of course, we should also try another paper. How about this one? It is about the Higgs boson and whether we can explain it with an alternative theory of particle physics. Sounds good. Let's ask the model. Please summarize this paper and indicate which sentences were most important in drawing the conclusion. It reads the paper and gives us a nice summary. Again, it found the key facts and figures. And now it is time for the test. Do they correspond to the correct passages in the text? Let's have a look. Yep, that looks good. It found the correct passages. That is excellent. You fellow scholars, this is a great leap forward. Being able to understand scientific papers is a huge step towards building good assistants for science. Just imagine a world where everyone has an assistant that can read papers, find the key facts, and even help with writing. This could greatly speed up the pace of discovery in all areas of science. What a time to be alive. You see, large language models are becoming more and more capable, and today we saw that they can even help us understand scientific papers. They can read them, find the important parts, and even cite the important passages. Truly amazing. If you enjoyed this paper, I have some more amazing papers that I think you will love. For instance, this paper is a culmination of several works that try to teach the model to reason scientifically. This paper is called Science GPT, and it does such a good job that it even fooled the humans. Some of the answers were preferred by humans over those of experts. And if you wish, you can even try it out for yourself. Just follow the link in the video description and have a look. This is a really amazing model, and it shows how capable these text-to-text models are becoming. Thanks for watching and for your generous support, and I'll see you next time.